In the darkest corners of the universe lurks a force beyond comprehension, a black hole, where light cannot escape and time itself begins to unravel. A dying star collapses, its final breath igniting a gateway to the unknown. Join us on a journey into the very heart of the universe's deepest mysteries through the most breathtaking simulation you've ever seen with SYNRIX.
Mysterious, powerful, and invisible. These cosmic giants are born in the final, violent moments of a massive star's life. Deep in the heart of a star many times the mass of our Sun, nuclear fusion has burned for millions of years, producing light and heat that push against the force of gravity. But eventually, the star runs out of fuel. Its core begins to collapse. Under the immense weight of its own gravity, atoms are crushed and the star grows unstable. As we approach the dying giant, we can see its surface erupting, shedding particles and glowing brighter, hotter, and more chaotic. Then, in a fraction of a second, it explodes. A brilliant supernova tears through space. At the center of this explosion, a new object is born. A black hole. A place where gravity wins, where matter collapses beyond imagination, and where the laws of physics begin to break down. In the aftermath of the explosion, only silence remains, except for the growing pull of gravity. From the ashes of the dead star, a black hole emerges. A dark center surrounded by dust and gas spinning around it. Matter caught in its grip forms a glowing accretion disk spinning at near light speed, heating to millions of degrees. As we draw closer, space itself begins to distort. The background bends, light twists, even reality appears curved. Orbiting around this invisible core, we see the true face of a black hole, not in its darkness, but in the chaos it leaves around it. The first type of black holes, that is the most common kind, is the stellar mass black hole. These are created when massive stars, typically more than 3 times the mass of our Sun, run out of nuclear fuel and collapse under their own gravity. To put that into perspective, imagine a star over 1 million kilometers wide collapsing into an object barely 30 kilometers across. That's like turning the size of a soccer stadium into a marble. In comparison, this black hole's diameter is less than 0.5% of Earth, but stellar black holes are just the beginning. The second type is the intermediate mass black hole. For a long time, they were purely theoretical, but now we've begun to detect them through gravitational wave signals and unusual star cluster behavior. These black holes typically range from a few hundred to 100,000 times the mass of the Sun. Even though they're physically small, their mass is staggering, over 300 million times the mass of Earth. The surrounding gas can heat to tens of millions of degrees, forming a fainter but still deadly accretion disk. And then there are the true giants, supermassive black holes. These monsters sit at the centers of the most galaxies, including our own Milky Way, and weight millions to billions of times more than the Sun. Take Sagittarius A, the supermassive black hole at the center of our galaxy. It has a mass of about 4 million suns and a diameter of roughly 12 million kilometers. That's almost 1,000 times the size of Earth. In more extreme cases, like the black hole in the galaxy M87, the mass can reach over 6 billion suns. Not all stars meet a peaceful end. Sometimes a star ventures too close to a black hole. Its outer layers are torn apart by immense tidal forces, ripped into glowing streams of gas. These remnants spiral inward, forming a brilliant accretion disk. The matter heats up to millions of degrees, emitting X-rays as it races toward the event horizon. Slowly, inevitably, the black hole fades. What was once a shining star is now vanishing into darkness. But what if we could get close, really close to the event horizon? What would we say as we cross that final boundary? The boundary where time and space begin to lose their meaning. From a distance, space appears distorted, stars curve, light bends, gravity begins to warp reality itself, reflection twists back towards us, the colors shift to deep blues as gravitational redshift takes hold, the ship trembles, time slows, space stretches, and then we cross the horizon. Inside, there is no turning back and no escape. Beyond this threshold, we face the unknown, where our understanding ends and mystery begins. So what lies inside a black hole? Is it true annihilation? A place where matter, time, and even space itself cease to exist? Or is it something else? Could it be a tunnel curving into a higher dimension beyond our comprehension? A bridge, a wormhole to a distant corner of the universe? What if what we see at the end is actually a transition? Not destruction, but transformation into something we can't yet imagine. Maybe the end of one reality is the beginning of another.